In this video, we're going to look at how RDMP loads DICOM images and how we can link the resulting dataset with other health datasets to perform an anonymous extraction for a research project. All of the data used in this demo has been randomly generated for the purposes of testing. We will start by looking at how we load DICOM images into the relational database. This involves extracting the file location and relevant tags such as modality, patient ID, and study description from the images. We will be using the tool BAD-DICOM to generate some test studies using the same seed as the regular test data already held in this RDMP instance. In order to process images, we will need the RDMP.Dicom plugin. A link to the plugin can be found in the description below. Once the plugin is loaded, we will need to create a new DICOM imaging dataset. In this case, we are going to create a dataset from the template for CT scans. The template lists all the DICOM tags we want to extract from the images and which tables they should be put into. Again, these are only the tags needed for cohort building and linkage. We will also load the file location so that we can retrieve it later for anonymization and extraction. This template includes 3 tables: the study table, a series table, and an image table. The study table contains all the tags that do not vary during a scan, such as the patient ID, study date, and study description. The wizard has also created a data load which will allow us to load DICOM images into these tables. The component responsible for reading DICOM tags from the images and storing them in the appropriate table is the auto-routing attacher. We will need to tell the attacher which directories to load DICOM images from. When we run the load, all the images from the directory will be loaded into the target tables. We can see that the load has populated the tables with data read from the images. Although there are only 10 studies, each study has hundreds of images. Next, we will build a cohort by linking the biochemistry and study datasets. When we run the configuration, we can see that there are 9 unique patients that have had CT scans and 4,289 unique patients who have had biochemistry test results. We can generate a graph of the intersection to see which biochemistry tests have been performed on the CT patients. Let's add a restriction to the biochemistry cohort set to match only patients who have had an ALT or BIL test. This brings our count down to 882 unique patients in the biochemistry dataset and gives an intersection of 4. We should update the cohort description to match our new restrictions. Once we are happy with the query, we can commit the final cohort list into the cohort database. We will need to create a project and name the cohort. Next, we select a pipeline for committing the cohort. We can see that our patient identifiers have been given an anonymous GUID mapping. Next, we will look at how we extract images from our database in an anonymous form. In order to extract the linked datasets, we will need to create an extraction pipeline. We can do this by cloning the existing extraction pipeline and adding the RDMP.Dicom Anonymizer plugin component. This component requires that we tell it what column in the database contains the image file path, what output folder to put the anonymous images in, and a UID mapping database for storing substitutions in. This mapping database applies to SOP instance UID, series instance UID, and study instance UID tags. We will need to create an extraction configuration for our project. We will need to specify the cohort and which datasets we want to extract, including the imaging table. When we run the extraction, we can see each dataset being linked and extracted to disk. In the case of the CT image table, the output directory will also contain the anonymized DICOM images. All identifiable information has been removed from the DICOM image, including unique identifiers, patient ID, date of birth, postcode, etc. CSV files and metadata are also generated for all datasets, including the CT image dataset.